Hello Math 7 students, this is a review video for our proportions test coming up. To get started on our review, I want you to write the equation that you see in this graph. We haven't had very many opportunities to do this, but based on our lesson and what we did in the review yesterday, or in 4.2H, you should be able to do this. Here's a hint: if you're stuck, start a table. Make a small little table with the information that you see in that table, and it will help you. Pause the recording and get that done. We'll come back together to check. Okay, let's go over this. As I suggested, you should make a table with the information that you have, because we are not used to writing equations from a graph, but we are used to writing equations from a table. So take the information from the graph and put it in a table. The ones that we saw in class yesterday on 4.2H, they were easy equations to write because we could see exactly how high up that unit rate was. We can't see that here. It's somewhere between the 0 and 1, but we don't know exactly where. So setting up the table is going to be your best bet, and it doesn't need to be a very big table. But with this point, I can tell, remember, this is our x comma y. So this means the x value is 10 and the y value is, I'm sorry, not 10, I don't know where I got 10 from. The x value is 5 and the y value is 3. There aren't any other points that are very easy to judge except for this one. You can see that that goes through a crosshair point, and if you count to see what the coordinates are, this is 5, that's 6, 7, 8, 9, and 10. And this was 3, 4, 5, and 6, so there's the coordinates 10, 6 if we wanted to have another point on our table. You could have done it without the second point, but the second point just confirms what that constant of proportionality is. And I don't know what the constant of proportionality is. I don't know what a 5 needs to multiply by in order to become a 3. And since I don't know what that is, I'm going to use that handy strategy of working backwards. When I work backwards, I'm going to be dividing. So I end up with 3 divided by 5. In your calculators, it will simplify it to the fraction 3/5. Or you can force it to a decimal and say 0.6, that's also acceptable. But we're multiplying by 3/5, and if we're multiplying by 3/5, that means x in this column will be multiplied by 3/5 to equal what's in the y column, and there's your equation. X times 3/5 is equal to y, or y equals 3/5 x. And another acceptable version of that is just, instead of 3/5, if you put y equals 0.6, if you converted that fraction to a decimal. So again, all the information that you needed was there. There's no reason to try and guess to see what you think that unit rate is, because there's enough information on the graph that you can find it. But now, I hope that you can see that this confirms exactly what that unit rate is. 3/5 is between 0 and 1. Looks like it's a little bit higher up than halfway, just like those numbers say it should be. So don't try and estimate what it looks like. There is information. Use that information to write an accurate and precise equation. And now on to the review. This is reviewing proportions, so whatever unit it is, this is the proportions review, so that's why I've scribbled out where it says unit 1, because that was inaccurate. This is our, I think, our third unit actually. So we're going to get started on this. Let's start by reading the problem. In this following problem, one representation of a proportional relationship is given. You need to complete the other representations. You're going to notice we have a blank table, a blank graph, and a blank equation. So what is the representation that's given to us? It's a story. On a map, 1 centimeter represents 25 miles. So you need to complete the table, graph, and the equation to represent the situation. Once we do that, we have some more questions to answer. Let me give you a hint. Please notice on the table, the top row should always be labels. Yes, we have our x column and we have our y column, but I also want us to recognize that the x column and the y column are going to represent things in that story. So we should also give it that type of a label as well. So on a map, 1 centimeter represents 25 miles. I'm going to go ahead and put in the left column centimeters, and in the right column miles. Now that I have my labels set up, now I can take the information that's given to me in the problem, 1 centimeter, so that's going to be a 1 in the centimeter column, represents 25 miles, that's going to be a 25, in the miles column right across from that one. From there, we can find that constant of proportionality. So I'm going to pause the recording and let students work ahead, and then we'll come back to check the answers. This is a good opportunity to review on your own. Treat this like a test question. If it were a test question, what would you do? And would you get it right? So pause the recording, try it first, and then come back and we'll do it together. Okay, we're back. Let's go over this then. Now, in this table, it doesn't have specific values that we need to find. So you get to choose what kind of information you want to put there. And the choice really, truly is yours. So you can choose any number you want. If you really wanted to, you could put 100 centimeters. However, given the situation, since centimeters is a map, does it make sense to talk about 100 centimeters? Would you really have a map that's quite that large? Probably not. I'm guessing it's probably going to fit on your little desk, so it's probably not going to be 100. So you can put any numbers you want here in the table. I like to go a few in order. 1, 2, 3. Maybe I'll skip ahead to 10. And maybe I'll include 0, because I always like 0, as we saw in our video yesterday. 0 is an important one, because if it goes through the origin, then it's going to be proportional. So I like to include that information on the table so we can identify whether or not it's proportional. From here, we can see a 1 is going to change to a 25 by multiplying by 25. So, because this is a proportional relationship, it tells me right here, it is a proportional relationship. I know that I'm going to be multiplying by 25 everywhere else on the table. So that consistency allows me to fill in the rest of this table. 1 centimeter is 25 miles. 2 centimeters is going to represent 2 times 25 is 50 miles. 3 times 25 is 75 miles. 10 times 25 is 250 miles. And 0 times 25 is 0 miles. So we can see that this represents the origin, that point 0, 0. So it is going to go through the origin. I'm going to jump to the equation. Again, you are welcome to use C and M for centimeters and miles, but I like the consistency of X's and Y's. And what I can see is if I'm in the X column, I simply multiply by 25, and it's going to give me what's in the Y column. That gives me the equation X times 25 equals Y, or Y equals 25X. The real challenge comes from what are we going to put for our labels and our scale here on the graph. So I want to check in with the students in the class. How did you label and scale the graph? Starting here, what's going to go on the x-axis? Zuri. Yeah, we're going to be measuring centimeters on the map. And since we're measuring centimeters on the map, what's a good scale? What would we do here? What would we be counting by? Gideon? Ones. Okay. So I'm going to count by ones. This is our y-axis. What are we going to be measuring on the y-axis? Since this one's centimeters, obviously this one's going to be miles. What am I going to count by? What's a good scale to use? Luke? Yeah, I would use 25s. And if you wanted to use something different, that's fine. You can use something different. It's just going to make your graph look a little bit different than mine. Now, I'm going to go over a very common mistake that I see on a test every single year. So eyes on the screen. I know nobody made this mistake because I already saw your graphs as I walked around the room, but let me show you a very common mistake. They're like, okay, 1, 2, 3, the next thing in the table is 10, so I'm going to put a 10 here. And the next thing on the table is a 0, so I'm going to put a 0 here. Talk to your groups about why that's not a good idea. Okay. Now let's come back together. Here's the one thing that I need you to understand to avoid making this mistake. This amount of space, we have chosen the scale of 1. So this amount of space represents 1. 1 more is 2. 1 more is 3. Here's that same amount of space again. 1 more than 3 is going to be 4. So the one thing that students need to understand when they're making their graph doesn't have to represent all the exact same information you see here. It should represent the same relationship. But if I am graphing, and let's say maybe I decided to plug in to the table 50, that's going to change what this is over here. Am I going to be able to fit 50 centimeters here on the table or on the graph. No, and that's okay. It doesn't have to fit on there, but the things that should fit should be on there. So again, let's continue on with this. If this amount of space is 1, 1 more is 2, 1 more is 3, 1 more is 4, 1 more is going to be 5, and so on. Okay, we need to make sure that we understand that. Similarly, I'm just going to have to delete that. When I'm scaling up this way, I can see this amount of space here going up represents an amount of 25. So 25 more is 50, and another 25 is 75, and another 25 is going to be 100. So we need to make sure we understand what we're doing when we are scaling that graph. We're not just writing down the things that we see in the table. We're picking a scale that makes sense, being consistent with that scale, even if I'm lazy and I'm going to start skipping. So I don't want to label this one, but I know it's going to be 125. There's another 25, that's going to make that 150. So even though I skipped this, I still represented it as if it was there. 150 plus 25 is 175, but I'm going to skip it. Another 75 makes that 200. Another 25 and another 25 makes this up here 250. Similarly, there's that 1, 2, 3, 4, 5, 6, 7. So even though I skipped 6, I still represented it just by skipping the count. 8, 9, and 10. And now I can plot my points. And I see for this first one I'm going to go over 1 up 25. So over 1 up 25. The next one is over 2 up 50. So over 2 up 50. Over 3 up 75. Over 10 up 250. So over 10 up 250. And the last point that I need to put on there is that point 0, 0. Over 0 and up 0. Check in with your groups. We've talked about this before. Should I connect these dots with the straight line? Or should I just say, yep, it's forming a straight line, but not actually draw it? Dots or line? Check in with your groups. Ready, set, go. Okay, and now back to me. What is your final vote? Should I connect these with a line or just keep them dots? Why a line? Tell me why a line. Carter? Yeah, but even if we didn't have the line, it would still be constantly changing in the same way. So why do I need to draw that line? Let's go to Gideon. Yeah, they would all have a meaning. So for example, instead of just picking 4 centimeters and 5 centimeters, could I pick 4.2 centimeters? Yeah, 4.2 centimeters is still going to represent an actual distance. And here, 7.99 centimeters. 7.99 centimeters is still going to represent an actual distance in miles. So every point that's on that line still has meaning for the situation. Part A and B. You can answer them any way. You can use the table. My favorite way to answer these questions is with the equation. So I need the class, even if you did it a different way, how am I going to use this equation? I'll write it again, y equals 25x. And it says, what is the actual distance between two cities if they are 3.6 centimeters apart? How do I use the equation to answer this question? Go ahead, Alexis. Exactly. When I'm telling you 3.6 centimeters, I'm telling you what x is. X is 3.6, so I'm just replacing that. I'm substituting that in. So the equation was y equals 25 times x, and now it's y equals 25 times 3.6. I can't do that one in my head, so anybody who has already calculated that and used their calculator, please tell me what you got. Go ahead, Liv. 90. Y is equal to 90. So how far apart are they on the map? We would say 90 miles apart. Make sure we use our unit of measure. Make that quantitative. B, y is equal to 25x. Again, using that equation, y equals 25x. The actual distance between two cities is 360 miles. How far apart are the cities on the map? How am I going to use the equation to answer this question? All right, go and check in with your groups. We're going to pause recording while students check in with their groups. Okay, how do I use the equation to answer part B now that you've had a chance to check in? I'll wait. I heard all that talking. I want to see all the hands. Thanks. Devin. Yeah. Okay, pause there. Great job. What he said, just repeating it for the recording, this time it's giving me 360 miles. That's telling me what the y value is. So I'm replacing the y value, or the y variable, with the value of 360, just substituting that in. So now I have this equation, 360 is equal to 25x, and now we have to solve that equation for x. So what's happening to x? We can see we're multiplying. I'm going to undo that multiplication with division. And whatever I do to one side, I do it to the other side. And so I end up with x is equal to, what did you get, Devin? 14.4. 360 divided by 25 is 14.4. But what does that really mean? How far apart are the cities on the map? 14.4 centimeters apart. Okay. Great job. That's basically as hard as it gets. This ties in all of the different representations, writing an equation, creating a graph including the scales, figuring out what you want to put on your table, including the labels, and that's basically what proportions are all about. The only other things that we're going to be seeing throughout the rest of this review are some more with unit rates and tying that into constant proportionality. So that's what we're going to be seeing here. 2 and 3 are very similar problems. Here I'm giving you a situation and I want you to find the cars per boy. Understand what that means. That means we're finding the unit rate. And the next one, the information is organized in a table, and I want you to find the unit rate, and I want you to find the constant of proportionality. Similar ways of doing those kinds of problems, different ways that we would talk about them. So make sure that you have a good solid understanding of what a unit rate is and how we would answer that, and what the constant of proportionality is and how we would answer that. Pause the recording and give number 2 and 3 a try before we go over it together as a class. Okay, let's go over it together now as a class. Shelby has twin boys. She buys a box of 10 cars to share evenly between the boys. So I want to know how many cars per boy. You can just fill in the blank, but we've always shown our work in a very specific way. When it's a unit rate, I start at the end. I see that it says cars per boy, and I know that that means per one boy, and that tells me at the end of the problem I'm going to have 1 in the bottom, and the unit thing that we're measuring on the bottom is boys. So 1 boy in the bottom. And if boys are going to be in the bottom, reading the rest of that, that means that the cars are what's going to be in the top. So I'm setting up the end of my unit rate. And now that I know what the end of that unit rate looks like, I know what the beginning needs to look like. That means I'm going to have cars in the top part of that ratio, and I'm going to have boys in the bottom part of that ratio. And I'm going to fill in the information with the given information. She has twin boys. Twin boys means that there are 2 boys. She bought 10 toy cars, so that's going to be 10 cars in the top. And now that I've got this set up, I now ask the question, okay, how does a 2 change to a 1? We divide by 2. So that means I'm going to take that 10, divide it by 2. 10 divided by 2 is equal to 5. So 5 cars per boy, and now I can just fill in that blank. 5 cars per boy. This is how we've shown our work, with those equivalent ratios to find that unit rate. With that in mind, that sets us up a little bit more for number 3, where I'm asking both what is the unit rate and what is that constant of proportionality. So the constant of proportionality is me saying, how am I going forward across this table with multiplication? How does a 4 change to a 60? How does a 2 change to a 30? Now I can do that one in my head. Maybe you can't. And if you can't, that's okay. That's why we work backwards. So in my calculator, if I was trying to find this, because I didn't know how to go forwards, I would type in to my calculator 30 divided by 2. And that tells me 30 divided by 2 is 15. So I now know that I'm multiplying by 15 to go forwards across the table. 2 times 15 is 30. 4 times 15 is 60. So the constant of proportionality, by definition, is the number that we multiply by as we go forwards across the table. So it's just the number 15. How is that similar and different to the unit rate, push-ups per day? I'm going to show how we can find a unit rate a little bit differently. let's say it is just 1 day in the table. And it's not there, but I'm creating it now. 1 day in the table, we're going to multiply by 15, and that's going to give me 15 push-ups. Whenever you see that 1 in the table, not only does that make it the easiest place to find the constant of proportionality, it also tells you what the unit rate is. This is 15 push-ups in 1 day, or 15 push-ups per 1 day. Okay, same number. A unit rate is a ratio per 1. A constant of proportionality is just a number. Here are some more situations involving unit rates. Again, this time we need to find 2 unit rates. We had a whole lesson that was like this. Here's what we're talking about. Miles per hour, but then that can be reversed to its reciprocal, hours per mile. So we need to find 2 unit rates for each of these problems. Pause the recording and give it a try now, and then we're going to come back together and try it together. All right, number 4, Yvonne drove 357 miles on 10 gallons of gasoline. So what I'm finding, if I'm finding 2 unit rates, I'm going to do one ratio where it's miles per gallon. And then the second ratio where I'm going to change it to its reciprocal and go gallons used per mile driven. Okay, so setting both of these ratios up with the given information, that's going to give me 357 miles for 10 gallons. And I'm going to go ahead and set this one up too. That's going to be 10 gallons for 357 miles. And now that I have those ratios set up, now I can turn each of them into a unit rate, meaning I want it to be per 1. So this one, I'm going to change the 10 gallons to a 1 gallon. This one, I'm going to change the 357 miles to 1 mile. We always want that 1 to be in the denominator. So the 10 changes to a 1 by dividing by 10. I'm going to go ahead and divide by 10 here as well. 357 divided by 10, I end up with 35.7 miles. Here, I'm going to change this 357 into a 1 by dividing by 357. And since I'm dividing the bottom part of that ratio by 357, I need to do the same thing here. 10 divided by 357. Who has that one for me? Does anyone have that already calculated for me? Go ahead, Carter. 0.028. Did I write that down correctly? Okay. And then the unit is gallons. Yep. So 0.028 gallons per 1 mile. I am going to save number 5 for students to work on at home. I'm not going to do that one together, but it's going to be basically the same as what we just did here. Set up your ratio, write the reciprocal, but find the unit rate of the original and the unit rate of that reciprocal. Let's take a look at the next ones. On 6 and 7, we are first going to find the unit rate, use the unit rate, or proportional equations to actually answer the question. Since we don't have an equation set up, that means if I wanted to, I would have to do a table, and that's okay. I could set up a table to see that this is 12 patients in 6 hours and find the constant of proportionality that way. That works. I can also set up a ratio, 12 patients in 6 hours. And the question is, at the same rate, how many patients will she visit in 9 hours? So that means I'm trying to turn this into a 9. Here's the problem though. I probably don't know how to change a 6 into a 9. And that's why we find the unit rate first. So even if you can do that in your head, this is always a good starting point. We know how to change a 6 into a 1. That's easy. And from there, we also know how to turn that 1 into a 9. So the unit rate can be really, really helpful for doing all of these calculations. That 6 changes to a 1 by dividing by 6, and the 12 is also going to be divided by 6. That tells us 12 divided by 6 is 2 patients in 1 hour. Now, we know that it's 2 patients in 1 hour. That 1 can easily change to a 9 by multiplying by 9. Doing the same thing to the top part of this ratio, 2 times 9 is equal to 18. So that's going to be 18 patients in 9 hours. Going to leave number 7 for you to do on your own to practice. I think I'm also going to leave number 8 for you to do on your own. This is one that is very similar to that very first one. I've chosen specific spots on the table for you to fill out, so I'm going to leave that one for you to do on your own at home as well. What's the reference, Luke? It's Wendy's. Wendy is making her famous chocolate milkshakes, also known as... Good job. Okay. Moving on. This final set of problems are asking, is it proportional? Are these proportional? Yes or no? Remember, we always need to explain. So in a table, what is it that I'm looking for to determine if it's proportional or not? What are some clues? Luke? Constant of proportionality. Is finding that it goes through the origin, is that going to be enough? No, it's a clue. It's helpful. But it's not always going to be enough. So let's do this one first. I see 0, 0, so I'm hopeful. I'm thinking, oh, I bet this is going to be proportional. Let's find that constant of proportionality. I have no idea how a 15 changes to a 234. Do you guys? I don't. So when I don't know how to go forwards, I'm going to work backwards. 2.34 divided by 15. Who's worked ahead and already has that one done? Grant, did you have your hand raised, Grant? What did you get? Oh, well, what's 2.34 divided by 15? Yeah, 156 thousandths, or 0.156. So that tells me what I should be multiplying by every place that I go forward. 15 times 0.156. Let's try it here. 40 times 0.156. And I got 6.24. But what does it say in the table? Not 6.24. So is this going to be proportional? I tried using the constant of proportionality that I got somewhere else. Ends up that it's not constant. So Grant came to the right conclusion. No, it's not proportional. No COP. No constant of proportionality. So don't be fooled by this. Just because you see that it goes through the origin, this is hopeful. This makes us hopeful, but we still have to check for that COP. Number 10A, is this one proportional? No, but it's a straight line. Doesn't go through the origin, so it's not going to be proportional. B, is it proportional? It's a straight line, goes through the origin, so yes. Straight line through the origin. And I really like these last two. 11, A and B. Are these proportional? Check in with your groups real quick. These are going to be the last ones for the recording, last ones in class. Will you please check in with your groups? 11, A and B. Are they proportional? Be prepared to explain why, yes or no. Okay, now come back to me. 11A, is it proportional? No. Easy, right? This is almost no brain power. We see that we're adding. So that's an easy answer. No, we're adding in the equation. But what about B? Is this one proportional? It is. Students sometimes are like, but it doesn't look normal. It doesn't look right. The key thing is, are we only doing multiplication or division in this equation? Then that makes it proportional. Y is being multiplied by 5, yes. X is being multiplied by 40, but it's just multiplication. And if we really wanted to, when we get into our equations unit, we're going to see if we wanted to get Y alone so it looks normal, we can do that. We just have to divide each side by 5. Now it divides out, and Y is going to be by itself, and 40 divided by 5 is 8x. Now it looks nice and happy, and we can see that, yes, this is proportional. Only multiplication. Folks, anything that we have not yet finished in class is homework. If you have not already done it, it is homework. And the answer key is in Canvas. So please check Canvas so that you can check your answers. That's it for today. Thanks for watching, and we'll see you next time.